everyone. Today, all are very much familiar with the term corona. In this video, we can see what is a corona discharge in an electrical transmission line. When an alternating potential difference is applied across two conductors, and if the spacing is large compared to diameters, there is no apparent change in the condition of the wires. But when the applied voltage exceeds a certain value called critical destructive voltage, the conductors are surrounded by a faint violet glow, and that is called corona discharge. The phenomenon of corona is accompanied by hissing sound, production of ozone, power loss and radio interference. If the voltage is raised, the larger and higher the luminous envelope becomes, and greater the sound and the power loss and radio noise. If the applied voltage is increased to breakdown value, a flashover will occur between the conductors due to breakdown of air insulation. The phenomenon of violet glow, hissing noise and the production of ozone gas in an overhead transmission line is called corona discharge. If the conductors are smooth and polished, the corona discharge will be uniform throughout the length of the conductor. If it is rough, the rough points will appear more brighter compared to smooth points. And also, in case of stranded conductors, the corona discharge will be more. And in DC system, there is a difference in the appearance of corona in two wires. The positive wire has uniform glow, whereas negative conductor has spotty glow. How the corona is formed? We can see some ionization is always present in the air due to the ultraviolet radiations and radioactivity. Under normal condition, the air surround the conductor will have some ionized particles, that is some free positive and negative electrons, and some neutral molecules. When the potential difference applied between the conductor is increased such that if it is greater than the breakdown strength of the air conductivity of the ionized particle increases. Under the influence of potential gradient, the existing free electrons acquire greater velocities. Greater the applied voltage, greater the potential gradient, and more is the velocity of free electrons. When the potential gradient reaches above the breakdown strength of the air, the velocity of free electrons increases and it will strike more neutral molecules and it will form more free electrons. Again, it forms a cumulative process and more collision will happen. The result of this ionization is that the corona is formed or spark takes place between the conductors. The main factors which affecting corona are the atmospheric condition, conductor size, spacing between the conductors and the voltage across the conductors. As the corona is formed due to ionization of air, it affects mainly by the effect of atmospheric condition. If it is a stormy weather, the number of ionized particles will be more compared to fair weather. So, at low voltage itself, the corona discharge will happen. And also it depends on the conductor size. If it is rough and irregular surface, more corona will occur at the irregular or uneven surface. And in case of stranded conductors, it gives more corona discharge compared to solid conductors. Then the spacing between the conductor. If the spacing between the conductors is very large compared to diameter, the corona discharge will be less due to the reduced effect of electrostatic stresses between the conductors. And the main factor is line voltage. If the line voltage is low, the corona discharge will be less. Then the critical disruptive voltage. It is the minimum phase to neutral voltage at which corona occurs. Consider two conductors with radius r cm spaced at a distance d cm apart. If V is the phase to neutral potential, then the potential gradient is given as G equal to V by R log D by R. Then if in order that corona is formed, the value of G must be equal to the breakdown strength of the air. The breakdown strength of the air is 30 kV per centimeter at a pressure of 76 centimeter and temperature of 25 degrees Celsius. So, if this value of G is more than the breakdown strength of air, the discharge will happen, and this voltage Vc at that point, the voltage Vc, that is the voltage between phase and neutral, is called critical disruptive voltage. So, Vc is given as Vc equal to G0 R log D by R, where G0 is the breakdown strength of the air. But G0 also depends on the critical disruptive voltage also depends on the density of air. So, in order to accommodate that, we can write critical disruptive voltage Vc equal to G0 delta R log D by R, where delta is the air density, which depends on the pressure and temperature. B is the pressure and T is the temperature. And also there is change in critical disruptive voltage depending on the surface condition of the conductor. So, in order to accommodate the surface condition, a factor called irregularity factor is accommodated, where M0 is the irregularity factor, then Vc equal to M0 G0 delta R log D by R. M0 equal to 1 for polished conductors and 0.98 to 0.92 for dead T conductors and 0.87 to 0.8 for stranded conductors. Then the another term is visual critical voltage. This is the minimum phase to neutral voltage at which corona glow appears all along the line conductors. That is visible corona discharge occurs at voltage above visual critical voltage. It has been seen that in case of parallel conductors, corona glow does not being at destructive voltage but at higher voltage than the disruptive voltage. We can see the corona discharge at a higher voltage than disruptive voltage, that is called visual critical voltage. So, with visual critical voltage is given as MV G0 delta R 1 plus 0.3 by root of delta R log D by R, where MV is the irregularity factor. This 1 for polished conductor and 0.72 to 0.82 for rough conductors. Delta is air density, D is the distance, R is the radius of the conductor. Then power loss due to corona. The formation of corona is always accompanied by energy loss in the form of light, heat, sound and chemical action. There will be formation of light and along with that heat production is there, hissing sound is there and chemical action is there. So, power loss is given as P equal to 242.2 into F plus 25 by delta root of R by D V minus Vc square into 10 raised to minus 5 kilowatt per kilometer per phase. It depends on the frequency of supply, phase to neutral voltage and disruptive voltage. Then advantages and disadvantages of corona. Due to the corona formation, one of the advantages is that the effective conductor diameter increases. That means when the corona is surrounded the conductor, the effective conductor diameter increases and it reduces the electrostatic stresses between the conductors. And also corona reduces the effect of transients produced by switching surges. Main disadvantages are corona is accompanied by loss of energy. This reduces the transmission efficiency and also it produces ozone and may cause corona also may cause corrosion of conductor due to the chemical action, and current drawn by the line due to corona will become non-sinusoidal, because the corona discharge may have frequency other than 50 hertz. So the current may become non-sinusoidal, so the voltage drop also may become non-sinusoidal, and which causes radio interference with neighboring communication lines. These are the disadvantages and advantages of corona. Then how we can reduce the corona? By increasing the conductor size, the voltage at which corona occurs can be reduced. That is the reason ACSR conductors have larger cross-sectional area is used in normal transmission line. And also we can reduce the corona effect by increasing the conductor spacing. If the spacing between the conductors is large, the electrostatic stress will be less, and the corona will occur at higher voltages. But we cannot increase the spacing to a large extent, because supporting structures will have more cost when the distance is very large. So these are the methods of reducing the corona. Okay, thank you.